PE Power Exam Specification and the Reference Handbook are undergoing changes on October 1st, 2025. If you are currently preparing for the PE Power exam and are about to take the PE Power exam, you basically have two options. Either you expedite your exam preparation and take the exam on or before September 30th, 2025, making use of the current exam specification and the reference handbook, or you take the exam on or after 1st of October 2025, which may require you to sort of give yourself a little bit additional time to adapt to the changes that are coming about. In the grand scheme of things, these changes are not as significant as the changes that happened on 1st of December 2020 when the PE Power exam switched from a paper and pen exam, an open book exam, to a closed book CBT exam similar to the FE Electrical and Computer exam. So before 1st of December 2020, you can quite literally bring in as many references as you wanted to the actual exam because it was an open book exam. Back then, NCS did not provide you any reference handbook. And in addition to the calculator, you were supposed to basically bring in your own codes and standards and reference material. But since that switch on 1st of December 2020, you are no longer allowed to bring in any reference material. So when we compare these changes to 1st of December 2020 changes, these are just incremental minor changes, but they're still significant enough for you to take into account the modifications and the updates that have been made, things that have been added into the specification, and the topics that have been removed. So without further ado, let us take a look at preparation approach and the guidelines for preparing for the PE Power exam post October 1st, 2025. The date, as I mentioned a few times already now, is 1st of October 2025, and the exam specification along with the reference handbook is undergoing some changes, which I'm going to try and summarize effectively for you, and your preparation should also adapt accordingly. So what you will use on the exam day from October 1st, 2025 onwards, version 2.0 of the NCS PE Power Reference Handbook. Now, as I mentioned, 1st October 2020 is kind of a critical date in terms of the PE Power exam, how it has evolved. And 2014 is a critical year for FE Electrical because before 2014, even FE Electrical used to be pen and paper. And up until 1st of December, PE Power was also pen and paper. Just like the FE Electrical and Computer exam, you now have reference material that is provided to you, a reference handbook. The reference handbook for the PE Power exam differs from the FE Electrical and Computer exam reference handbook in the sense that in the FE exam, if you've recently taken the FE Electrical and Computer exam after 2014, then you know that there is just one reference handbook, a PDF, that basically covers FE Electrical, FE Mechanical, FE Civil, FE Environmental, FE other disciplines, and so on. But when it comes to the PE Power exam, we have a dedicated, specialized reference handbook that contains the content and the reference material just for the PE Power reference handbook. Now, this reference handbook is undergoing some minor changes such that some of the content, as I am going to explain you later, is going out and some content is coming in. But for the most part, I would say about 85 to 90% of the reference handbook is still the same as the one that is in use before October 1st, 2025. From a reference material standpoint, another significant change that is happening is with regards to the codes and standards. So NEC up until September 30th, 2025, 2017 is going to be used, and similarly older editions for the NFPA standards. So if you are taking the exam on or after 1st of October 2025, it's very important for you to make sure that the reference material that you're using in terms of codes and standards are the same editions that are basically outlined in the latest exam specification for the PE Power exam. Now, those of you who have hands-on experience with codes and standards would recognize that when we move from one edition of the code to another edition, it is not a quantum leap. Typically, it's just incremental changes. And if we take this into consideration that 800 pages are present roughly in NEC, and how many of these pages get impacted, or how many code sections get impacted in NEC, you realize that about 1% to 2 or maybe 3% of the entire code is impacted in revision from one edition to another edition. So it's not a monumental change, but at the same time, since we are being explicitly told by NCES P power exam specification that the exam is going to be based on NEC 2020, that the exam is going to be based on 2021 for NFPA 70E, NFPA 497, NFPA 499, and 2023 edition for NFPA 30B. It is our responsibility to make sure that we actually make use of these editions so that our preparation is not off the mark. The only code that is not being impacted and we're still using the older edition is NESC, and that is 2017. The other change is that in terms of the resources, NCS, as you might have used their FE Electrical and Computer Sample Exam, also produces the P Power Sample Exams, and they have actually published a newer version of the P Power Sample Exam, which impacts roughly 8 questions out of 80, so roughly 10%, 8 to 10 questions. So please make sure that when you are preparing for the 1st October, post 1st October exam for the P Power, that you make use of the sample exam that is the latest and the greatest. In terms of the topics that are going out from both the specification as well as the reference handbook, we have engineering economics and reliability engineering. So there is a through line that basically runs through these topics, in the sense that engineering economics is not a power system focused topic. Similarly, reliability engineering is not a power systems focused topic. In the context of engineering economics, the important thing is that we have already been tested on NG-Con in FE Electrical and Computer Exam. If you remember, engineering economics was section number 4, if I'm not mistaken, in the FE Electrical and Computer Exam, standalone section with about 5 to 8 questions that could have been asked, and that might have been asked on your FE Electrical and Computer Exam. So in a way, it was a little bit redundant. So that's why it's been taken out. That's my understanding. In terms of reliability engineering is a little bit of overlapping discipline, multidisciplinary in some sense. If you work in operations, if you work in maintenance, and you would come across this quite often, but it is not core power systems topic, so it has also been removed. As far as some of the new topics that have been added, I'm going to explain them shortly, but a ripple effect of the removal of these topics is that the weightage in some of the existing topics which are carrying over from the current specification to this new October 1st specification, the weightage has gone up. Now, the weightage has gone up in these areas: circuit analysis, protection, and codes and standards. I'm going to explain each one of these topics briefly as to what are the commonalities between these three topics and why they're so crucial. So when we say circuit analysis, if you're coming from FE Electrical recently, probably DC circuit analysis comes to your mind: KCL, KVL, Thevenin, Norton, superposition, source transformation, and so on. Circuit analysis in the context of the PE power exam is a steroids version of your FE Electrical and Computer Exam specification circuit analysis, in the sense that all of your KCL, Ohm's law, that is taken for granted. That is the base fundamental stuff, right? On top of that, we have the three-phase systems, okay, which we did get exposure to in power system analysis while preparing for the FE Electrical and Computer Exam. Then we have per unit systems, which was not part of FE Electrical and Computer Exam specification. And then we have the symmetrical components. Why am I singling out these three subtopics within circuit analysis? The reason is that these three topics, your three-phase systems, your per unit system, and your symmetrical components, have an outsized impact on the rest of the P power exam specification. They show up in motors, in generators, they show up in transformers, auto transformers, fault analysis, both symmetrical and unsymmetrical, transmission line models, short, medium, and long, power system stability, power flow, and protection. So these downstream topics that I've mentioned, they amount for about 50% of the exam by weightage, give or take. And that 50%, you won't be able to make any serious progress with the remaining 50% of the exam specification until unless you have a solid understanding of these three topics. In my program, both the PE Power On Demand, PE Power Masterclass, as well as the PE Power Live Training Program, I actually go in depth with respect to per unit systems, with respect to three-phase systems, delta Y transformation, positive sequence, negative sequence, symmetrical components, and so on. So it's extremely important, and it's actually you're being rewarded. Now that the weightage has slightly gone up, you're being rewarded for having a good understanding of these core concepts. Now let's shift gears and briefly talk about protection. Fault analysis, relays, coordination, protective devices, and so on. Protection actually also builds on top of your circuit analysis. If you don't have a good understanding of three-phase systems, if you don't have a good understanding of per unit systems, if you don't have a good understanding of symmetrical components, you won't really be able to make any progress with fault analysis. You won't be able to make any progress with the relays, with the overcurrent protection, with the differential protection, with the distance protection, with the coordination, zones of protection, and so on and so forth. So circuit analysis feeds into protection, and protection itself then has an overarching impact on things like motors, things like generators, things like transformers, your conductors, because NEC 240 basically gets impacted. And that basically is a good segue to codes and standards, because NEC, if you are working as a practicing engineer, if you do design engineering, and you will come across, of all the topics, of all the standards that I've discussed previously, mentioned previously, NFP 70E, 497, 499, 30B, NESC, the one standard that has a lion's share of an electrical engineer's attention, time, and focus in practice, in reality, is NEC. You may never come across NFPA 497, 499, 30B until unless you work with classified areas. You may never come across NESC until unless you work in transmission and distribution. But NEC is one section, one code standard that basically appears over and over and over again in real life. So, similar to circuit analysis and protection, which have outsized impact on the rest of the specification, codes and standards, specifically NEC, can impact your grounding, your bonding, your PV systems, your motors, your generators, your transformers, your capacitors, your voltage drop, your overcurrent protection, your surge arresters, your lightning protection, even your lighting design, and so on. So it's very important for us to make sure that we are spending sufficient time, which I do in my program, and I basically have stepwise breakdown of the entire NEC in a multi-part lecture series so that we can actually maximize our return on the exam, because these topics are not in silo impacting the relevant sections. They basically branch out, and either collaterally they're going to help you, or collaterally they're going to damage your preparation overall. Moving on, we have new content, and we got to keep the strategy simple while dealing with this. First of all, we need to understand sort of the context behind this new content, starting with Boolean logic, right? In the new reference handbook, they've included gates and they've included truth table. Now, what we need to recognize is that this Boolean logic is in the context of ladder logic, PLC. Granted, we have AND, we have NOR, we have NOT gates being explained to us, right? A little bit of a Boolean algebra. But this is not digital systems section 15 of FE electrical and computer exam, which is one of the big 5 topics. Over there, Boolean logic is kind of a sidekick. Over there, Boolean logic sort of is under the shadow of your flip-flops, of your counters, synchronous, asynchronous counters, your K-maps, your number systems, your timing diagrams, your state diagrams, your truth tables, and so on. So Boolean logic is important, right, in the context of section number 15 of FE Electrical and Computer exam, but it is sort of a building block. Over here, we have to look at Boolean logic from the lens of ladder logic, right? PLC programming. So if this condition is true and this condition is true, then we are going to allow this relay to operate, right? If we have this permissive and this permissive, right? And if this interlock can be added in series, which makes it an AND gate, then what is going to happen? In my program, I systematically work through easy, medium, and difficult schematics, actual motor schematics, to help students understand the practicality of ladder logic diagrams in a very stepwise manner. I've always been doing that, and as part of this update, I have added new content in order to help my students further understand this and appreciate this. In terms of the electrical energy storage, so this is a line item that has been added, a brand new line item in the exam specification. Directly, no changes have been made in the reference handbook, which is kind of interesting because the reference handbook always had content on batteries, and that content has not changed. The batteries content that is provided in the NCES P Power Reference Handbook version 1.x and version 2.0, which is going to be in effect from October 1st, 2025 onwards, is focused on batteries in an industrial setting. It's focused on lead acid batteries, the primary batteries, the secondary batteries. It talks about the Peugeot's constant. It talks about theoretical capacity of batteries. So these are the type of batteries that you are going to use in the industry as a backup power for, let's say, your medium voltage switchgear circuit breakers, for DC battery chargers, and so on, for UPSs. But these are not the batteries that are used for mass storage, mass energy storage. And that brings us to ultracapacitors as well, which are not mentioned in the reference handbook. Ultracapacitors are different from your power factor correction capacitor, although they are both capacitors. The purpose of ultracapacitor in a nutshell is energy storage. The purpose of PFC capacitors, power factor correction capacitors, as the name states, is to provide reactive power, to provide voltage support, to improve the power factor, and to basically help us comply with the utility requirements so that we are not charged with penalties by the utilities. As far as the capacitors are concerned, this is not the first time we are seeing capacitors. We started seeing capacitors in the context of FE Electrical and Computer exam and the P Power exam as early as properties of electrical materials, section number 5 of your FE Electrical and Computer exam specification. I remember all of these sections inside out because I help my students not only with just FE Electrical and Computer exam preparation, or not only just the P Power exam specification. I basically conduct live training for my students, helping them all the way from section 1 of mathematics of FE Electrical and Computer exam specification to section 17 software engineering. And most of my students basically carry over their preparation into PE Power back to back, and I assist them with the entire PE Power exam specification. Anyways, coming back to capacitors, the first time we saw capacitors, if you've recently taken FE Electrical and Computer exam and passed the exam, is in section number 5, properties of electrical materials. Over there, there is a general introduction of the basic equations related to capacitors, Q is equal to CV, capacitor and permittivity, capacitor and the area of the parallel plate capacitors, the distance between the parallel plate capacitors, and so on. So that's an early introduction. In PE Power, we have been exposed to capacitors as well as in FE Electrical for PFC purposes. In PE Power, we also start talking about shunt capacitors for transmission line modeling, medium and long transmission lines. And now with the addition of this ultracapacitor, we now have to pay attention to the capacitors in the form of energy storage. Then we have alternative power generation. Although they've mentioned solar and wind, the reference handbook does not contain any detail. In my program, I already go in depth with PV systems, chapter number 6 of NEC, where we discuss PV requirements for alternative power generation. So long and short of these changes are that they are consistent with the industrial trend, minus Boolean logic. It's sort of an additional help for you to basically tackle the ladder logic related questions. But the industrial trend for electrical engineers, some of the really high power, high paying jobs, some of the growth areas within electrical engineering, power systems engineering is in the renewable space. So even if you don't have any background in renewable energy, the P Power exam is incentivizing you to learn the fundamentals of these trends so that you can have some basic level of competency. And in my opinion, these are very welcome changes. How do you go about your preparation? Remember early on I mentioned simple approach. The simple approach is not necessarily the easy approach. Simple approach is not to take the shortcuts. And there are two things that students who go through my FE Electrical and Computer Exam Preparation Program and the PE Power Exam Preparation Program recognize from the outset. And in the long run, they start appreciating it and liking it and adopt it as a way of learning moving forward. Okay. Level 3 understanding. Let me try and explain this very briefly. The way I approach learning and teaching is in the framework, using the framework of first principle understanding. What is first principle understanding? It basically means that you do not rely on scaffolding of fancy terms and definitions in order to sort of convey your point. Okay. It basically means that you understand the concept inside out with the help of unbroken chain of logical explanation and understanding. Baby steps, basically. Okay. So let's pick up a concept such as inflation, which is no longer in the P power exam, but those of you who recently passed FE Electric and Computer exam would recognize, and we all as consumers recognize what inflation is. We may be able to define it effectively as well. It is basically an increase in prices over a period of time when compared to a baseline bucket. So CPI, so Consumer Price Index, is typically considered a bucket of goods which are basically tracked, and then CPI basically gives you a sense of what the inflation is. So this is definition. This shows you that, okay, I have a level of understanding. I do understand the concept to an extent. And I would call this as level 1 understanding, where you sort of appreciate the definition, you're able to articulate what your understanding is. Level 2 would be if I can create a framework, if I can create a mathematical model or throw an equation at you, right, to showcase that, okay, on top of that definition, I'm able to do some numerical calculations, manipulations, and computations to figure things out related to inflation. So if you've recently taken the FE Electrical and Computer exam, remember that equation D is equal to I plus I multiplied by F, where D is the inflation adjusted interest rate, F is the inflation, I is the original interest rate, right? So you may get more impressed by me knowing that, okay, Wasim can actually work with a few equations related to inflation, but that is still level 2 understanding. Now, level 3 understanding is where not only you are able to understand that concept or use a mathematical formula. Mathematical formula sort of brings you to this plug and chug approach, which I'm going to talk about shortly. But level 3 understanding is that you are able to take this concept and apply this concept to another concept, and you can deal with problems that are multi-layered. Okay, so what is an example of a multi-layered problem? There are several examples. In fact, if you look at the P power sample exam, you're going to find a bunch of practice problems that they have provided that are multi-layered. But fault analysis, okay? So fault analysis practice problems, fault analysis is one of the more difficult topics for the P power exam. If you just take a plug and chug approach and you end up using a program that tells you that just use the MBA method, right? Do this, do that, and that will help you solve the problems. It's going to disappoint you on the exam because MVA method, for example, is only applicable to symmetrical three-phase faults. Fault analysis is multidimensional. You have to take a very immersive approach in terms of analyzing the nuances. For example, if you have a three-phase fault, that's a symmetrical fault. If you have a fault that does not impact all three phases equally, that is unsymmetrical fault. So that is at the definition level. Symmetrical faults only include the positive sequence components. So now we're talking about fault analysis, but where is this sequence component coming from, right? Remember I told you that three-phase systems, per unit systems, and symmetrical components impact everything else, and I actually circled fault analysis over there. So if we are dealing with three-phase fault, and I don't want to convert this session into a crash course on fault analysis, but just to give you an idea of the complexity and nuances and the convoluted nature of some of the abstract topics that you will encounter. And you will be at the crossroads of either taking a shortcut, right? Just a plug and chug approach, or really understanding things inside out. So, how do I tackle fault analysis? I go through full blown derivations in my program for three phase fault, for symmetrical faults, for single line to ground, unsymmetrical, for double line to ground, line to line faults. Okay, step by step, explaining you how the equations come about so that you can see the entire development of the skyscraper of understanding. So symmetrical components only include positive sequence. So without having positive sequence understanding, you won't be able to appreciate it. Now, if we are dealing with unsymmetrical faults, there is an entire category of SLG, DLG, line-to-line faults, and then there is another layer of complexity, whether the ground is involved or not. Because if the ground is involved, right, then you basically have the zero sequence components coming into play. And how is the ground involved? By involving the ground, is actually the current going into the ground, the fault current, or is the ground being involved or the impedance being involved without impacting the ground? Because in that case, our handling of the impedance is very different. So without us taking time to understand these concepts 360-degree and developing a level 3 understanding, you can find yourself in utter disappointment on the exam. And even if you're using XYZ programs, which are heavily focused on numerical problems and just a high volume of practice problems, the P power exam is going to be a different story. This plug and chug approach might have helped you in the FE electrical and computer exam, but for the P power exam, remember it's the last filter that they're applying. And it is extremely important for us to also look at it as an opportunity, not only to just simply pass the exam, get our license, meet the requirements, but also to brush up on our fundamentals so that we come at the other end, okay, after having gone through this preparation, having spent on average, by the way, students spend about 300 to 400 hours, sometimes even more, for the P power exam preparation. So after you have spent this much time and effort, you pass the exam, hopefully in the first attempt, if you're using effective exam prep resources and you have proper planning, execution, commitment. But the byproduct which you carry forward is a refined and refreshed understanding of all these convoluted concepts that might have always evaded you when you first got first exposed to them in either in your studies or at work. The second idea is that when you are using practice problems, they better be high quality practice problems. The practice problems shouldn't be such that they give you a sense of comfort, that they give you a false sense of confidence, actually. And you have to have time taken into consideration, although the timing requirements for the PE power exam is not as constrained as the FE electrical and computer exam. FE electrical and computer exam is quite literally a race against time, but the PE power exam is a different story. So we need to make sure that we are doing high quality practice problems, sample exams under time constraints. Within my FE electrical and computer exam preparation program and the P power exam preparation program, I have computer simulated practice exams with timers so that not only you can work with high quality practice problems with detailed solutions, but you can also time yourself along the way without requiring any external time watch. So resources tailored for post October 1st, 2025. So on my end, I have my FE electrical and computer exam preparation program, which is extremely popular, highly reviewed, my P-Power program, highly reviewed across all the platforms, YouTube, LinkedIn, Reddit. My study guide for P-Power is the highest rated book in the category of P-Power exam preparation. And the on-demand content is up to date. I have explicitly, because students are still taking the exam based on the current specification, and I've gone through multiple rounds of these updates over the last several years, both for FE electrical and computer exam specification update, the PE power exam specification update, and the reference handbook changes, the conversion of the PE power exam from an open book paper pencil to a closed book CBT exam. So I've gone through multiple rounds of these revisions and specification reference handbook updates. My content clearly outlines the topics which are no longer applicable post 30th of September 2025. So the students who are taking the exam before that do not feel disrupted. And as far as the new content is concerned, Boolean logic, as I mentioned, I already go through in depth in terms of schematics. Ultracapacitors, PV, and wind system is going to be effectively added in due time, not to basically disrupt students who are already preparing for the exam, but the content is all locked and loaded. And essentially, regardless of whether you take this exam before 1st of October 2025 or after October 1st, 2025, it is your responsibility, if you're investing in resources, to make sure and do your due diligence that they are being proactive, up to date, so that you're not spinning your wheels in the wrong direction. And my general recommendation to anybody who wants to pursue PE license is that you should consider starting your preparation, even if you're starting from FE Electrical, sooner rather than later. And for the simple reason, as time goes by, your personal and professional responsibilities typically increase. I know students who get done with the FE Electrical and Computer exam, who enroll in my program in the final year of their undergraduate studies, and then they jump right into the P Power exam after graduating and complete both exams back to back. This is allowed by a lot of states that have decoupled the experience requirements and they fully utilize it. So this is at one end of the spectrum. I have students in my program who've been out of school, FE Electrical, out of school for more than 20, 25, even 30 years. And there's several success story interviews over here. If you keep an eye on LinkedIn and Reddit, you're going to find several success stories over there as well, folks mentioning my program. And even for those folks, it's doable and they're able to pull this off, but it is significantly more difficult. But if where there's a will, there's a way, right? By starting your journey earlier, and the best time to start this was yesterday, the next best time is today. Starting your preparation earlier, you give yourself a little bit longer timeline, especially with the P Power exam. In general, the FE Electrical and Computer exam preparation takes about 3 to 4 months on average. Okay, although there is a broad range of topics that is involved in the FE Electrical and Computer exam, the P Power exam preparation is a little bit more focused, narrowly focused on power systems. The P Power exam prep typically takes about 5 to 6 months, sometimes even longer. About 400 hours for P Power exam prep versus maybe 200-ish hours for the FE Electrical and Computer. But these really depend on what your starting point is, on what the intensity of your preparation is, and arguably most importantly, the type of resources that you use. So my website, studyforfe.com, is a one-stop shop for both FE Electrical and Computer exam as well as the P Power exam preparation. And arguably, we all can figure things out on our own. There is no shortage of information in the current day. If anything, we have information overload with tons and tons of resources on YouTube, ChatGPT, Google, and so on. But the value proposition is the support system, is the crisp and simple and easy to understand, first principle based explanations that will help you develop level 3 understanding. And by trying to figure things out on our own, sometimes we can, if you have a lot of motivation, we can actually bulldoze through all the barriers and get the job done. But if you're working 9 to 5 full time, and especially if you are a P power candidate, most likely you are already working full time. 90+% of my students in the program, both FE Electrical and P power, are already working full time. On top of that, you have personal and professional commitments, right? So your time is premium. So in that sense, you got to make sure that every hour, every half an hour that you spend, every minute to an extent, right, is efficiently spent. So with the program that I've put together, which has yielded results for tons and tons of students across all the different age groups, experience levels, academic background, a lot of internationally trained engineers as well. Even a lot of non-electrical engineers have used my programs to pass the exams in the first attempt. And with the support structure that I have, an exclusive community of students, that support structure is going to help you get the job done in a short period of time. So if you're interested in streamlining your FE Electrical and Computer and P Power exam preparation, then please check out my website, studyforfe.com. Thank you.